All right, pre-calculus. Here is section 4.4 inverse functions. Here's the actual video for this. I know I gave you an intro video with a worksheet. Now we're going to look at the actual note section. So, inverse functions. The notation for an inverse is f to the negative 1 of x. And remember, that does not mean 1 over f of x. That is not what it is. Kind of weird, but that's sometimes when we see like x to the negative 1, it's like 1 over x. That's not what this means with function notation. So inverse functions, this is the thing that they use to notify that they're looking for an inverse. There are 4 steps. We talked about that in our intro video. The first thing is to change f of x to y. The second thing is to switch x and y. The third thing is to solve for the new y. And the fourth thing is to call it an inverse. All right, so the 4 steps. So if I do that to this particular one, now so you can see this one's a lot more difficult than the linear one that I showed you or the x squared one that I showed you. This one is now a cube. And so if I'm looking at this, I change the f of x to a y. Y equals x plus 2 cubed plus 3. Switch the x and y. All right, this becomes an x equals y plus 2 cubed plus 3. If I want to solve for this y, then I need to get it by itself. This is going to take some doing. So the first move I'm going to make is to take this 3 and bring it to the other side. So now I have x minus 3 equals y plus 2 cubed. I'm trying to get at this y. That's what I'm trying to get to. And I've got all this stuff going on around it that's making my life miserable trying to get to that y. The first thing is that quantity is being cubed, and I need to undo the cube. So in order to undo a cube, just like if you were to undo a square, you need to use the roots. So I'm going to cube root both sides. I'm going to cube root this side, I'm going to cube root this side, because if I cube root a cube, it undoes it. So here's what I'm going to have next. I'm going to have the cube root of x minus 3 on the left equals y plus 2. Now I'm running out of some space, so I'm going to come over here. I want to get the y by itself. I'm almost there, y equals the cube root of x minus 3, and then I'll have a minus 2 on the outside because this 2 is going to swing to the other side of the equal sign. That is the inverse, and I'm going to call it the inverse. The inverse is the cube root of x minus 3 minus 2. All right, so then they want us to graph it. Well, graphing it's kind of interesting, and I didn't talk about this much on the intro video that I did and the examples that I did there. But say I take some points that are here. Now you want to find friendly points that are going to be nice in the midst of your function. If this is your function, here are some nice points. What if x were negative 2? Negative 2 plus 2 is 0. 0 cubed is still 0, and 0 plus 3 is 3. What if I picked negative 1? Negative 1, and I'm in my original here, negative 1 plus 2 is 1, 1 cubed is 1, and 1 plus 3 is 4. You can see from the picture here that it should kind of line up. Negative 2 is 3, negative 1 is 4. Let's see, if I go a little bit further over, if I go negative 3, let's see what that brings me. Negative 3 plus 2 is negative 1. Negative 1 cubed is still negative 1. And negative 1 plus 3 is 2. And we'll try one more. We're going to do negative 4. Again, you can pick any numbers you want. I'm just picking numbers that are somewhat friendly. So negative 4 plus 2 is negative 2. Negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8. And negative 8 plus 3 is a negative 5. Negative 4, negative 5, that kind of makes sense in the picture. So once you have that, and then you want to do what the inverse ones are, And again, I didn't talk about this in the intro video, but it's kind of cool. Remember step number 2 right here where you're switching the x's and the y's? Well, guess what? Table-wise, you can do the same thing. You don't have to recalculate out all those points. You can just make your x column be your inverse y column, -2, -1, -3, -4. And your x's now are going to be what the y's were in this column. They're going to be 3, 4, 2, and -5. You switch them. Switch your x and y's. And let's see if that works. Here's my inverse equation, right? If I put a 3 in there, 3 minus 3 is 0, cube root of 0 is 0, 0 minus 2 is -2. I put a 4 in there, 4 minus 3 is 1, cube root of 1 is 1, 1 minus 2 is -1. I put a 2 in there, 2 minus 3 is -1, the cube root of -1 is -1, and -1 minus 2 is -3. And if I put a -5 in there, I get -8. Cube root of -8 is -2. And -2 minus 2 gives me -4. So it all works. It all fits. So you can switch your columns, and that makes life very easy. So all you need to do now, this one's already graphed for you. This is your f of x. If I do the inverse, let's plot these points. 3, -2. 4, -1. 2 is -3, and -5 is -4. -5, -4. So you can see how this guy's going to go. He kind of comes along this way and goes like this. He squiggles like that. And we did talk about this in the intro video. One of the interesting facts about inverses, and I'll put it in our margin over here, inverses are symmetric with the line y equals x. All right, so let's see. Here's the line y equals x. It's the one that goes through the origin. Here it is. Kind of crooked there, right? There is my graph. This is my line y equals x. It is symmetric. If I were to fold that over the line, you've got the picture there of both of those functions. Okay. So then he went on to the next example, and the next example was of a square root. So same idea. Our job is to find the inverse. All right, so we're going to go through our steps. We're going to check out the steps. Step number 1 says change f of x to a y. So y equals -2 square root of x minus 3 and then a -2. Step 2 says switch the x and y. X equals -2 square root of y minus 3 with a -2. Solve for the new y. Well, the new y is like, he is hard to get to. You got to dig to get to him. So the first thing you're going to do is take this 2, the -2, and flip it to the other side and get an x plus 2. -2 square root of y minus 3. Again, you're digging to get to the y. So your next step is to divide by this -2. You want to get this piece with the square root by itself so that then you can undo the square root. So I'm going to take x plus 2 divided by a -2 equals the square root of y minus 3. Shoo! I want to get rid of the square root. I have to square both sides. Square both sides. Well, over here that's pretty because that's going to give me just a y minus 3. So I'll have this crazy fraction x plus 2 over -2 squared equals y minus 3. And then you want to get the y by itself, so you're going to add 3 to both sides. And here's what your y is going to equal, which you're going to call the inverse. I'm going to kind of put those two steps together since I'm running out of room. I have x plus 2 over -2 squared, and if I bring this 3 to the other side, it's a plus 3. That is my crazy inverse. Well, they want me to graph it, so I'm going to go back and make a table of values. If I look at my table of values, let me move this over just a little bit. I'm going to talk about my f of x function. So if I have x and f of x, or my y's, same idea. And I'm going to talk about my inverse function. I'm going to have an x column, and I'm going to have my inverse column. So let's go back to our square root. Now pick nice numbers. So remember, you can't have negatives in the midst of this. So like say I pick 3. 3 would be a nice x value to pick into my f of x function. 3 minus 3 is 0. 0 times negative 2 is still 0. And 0 minus 2 is a negative 2. If I go to another nice number, pick a nice number. If I pick 4, 4 minus 3 is 1. The square root of 1 is 1. 1 times negative 2 is negative 2. And negative 2 minus 2 is a negative 4. So when I picked 4, that gave me negative 4. Square roots. Think of nice square roots. A nice square root would be the square root of 4. In order to get the square root of 4, this would have to be 7. So let's pick 7 as another number. 7 minus 3 is 4. The square root of 4 is 2. 2 times negative 2 is negative 4, and negative 4 minus 2 is a negative 6. Let's plot those points. Remember what a square root graph looks like from the last section? You got 3, negative 2. You have a 4, negative 4. You have a 7. Well, that's going to go off the graph, but that's okay. Negative 6. That would be kind of in this hood. Oh, you can't see me. Now you can see me. Here's my graph. All right, if I go to graph the inverse for this one, all I need to do is do the switcheroony of my columns, right? We talked about that back in the last problem. So now my x's become negative 2, negative 4, negative 6, what my y's were. And my x's become 3, 4, and 7. And so now I'm going to plot those points. So if I take those points and put them on my graph, I have a negative 2, positive 3. I have a negative 4, positive 4. I have a negative 6, positive 7. Again, it goes off the graph. So this one goes this way. So then the question is, check it out. Is it symmetric with that line y equals x? Well, let's see. If I were to fold that graph over that line y equals x, would they match up? Would they lay on top of each other? And the answer is yeah, check that out. They will. They're perfectly in line with one another. So now let's talk, we haven't talked domain and range yet, right? But we talk domain and range all the time. For this one, let's go with the original function. Well, the original function is this guy. Here's my f of x. This guy is my inverse. So if I'm looking at this, how far left, how far right does he go? His leftmost point is 3. Does it touch it? Yep. His rightmost point goes to infinity. The range is lowest to highest. The lowest it goes is to negative infinity. And the highest it goes is to this y value of 2. Does it touch it? Yep. If I look at the domain and range for the inverse function, that's this guy. Left to right. Left is negative infinity. Furthest on the right is negative 2. So this one's negative infinity. Negative 2, does it touch it? Yes. Range is lowest to highest. The lowest it hits is 3, and it goes up to infinity. Yes, it touches the 3. What do you notice? Do you see it? Can you see it? The domain and range have switched, right? They've switched each other. Which kind of makes sense if you think about it, because if your x's and y's have switched, then so has your domain and your ranges, right? Domain is x, range is y, they're going to flip. So it all kind of comes in and makes some sense. Okay, if I go to, do these functions have inverses? Remember, they have to pass the horizontal line test. They're asking just if it has an inverse, so all you need to worry about is it passing the horizontal line test? This guy, no. This guy, no. This guy from a table of values. Now, if you're looking at it, you're not allowed to, for the remember how with the vertical line test you couldn't have repeating x's? This time you can't have repeating y's. If you had to, plot the points. Plot the points and see. But this one, if I look at it, I can't have the y's repeat. Well, I have a 5, a 7, a -5, and another 7. You see how these 7s repeat? That's not going to work. This one is going to be no. Doesn't pass the horizontal line test. You have repeating y's, which are not allowed. Repeating y values. All right, that takes care of page 1 of your notes. Let us go to page 2. All right. They did not give you the mapping. Let me show you what the mapping should have been. Here it is. Remember we did these a long time ago, deciding if something was a function or not. I have in this left-hand bubble a +2, a -3, 147, and 2.1. Talk about arbitrary numbers, right? On this side I have a 7, an 8, a -4, and a 0. And here's how the mapping goes. 2 goes to 7, -3 goes to -4, 147 goes to 8, and 2.1 goes to 0. Is that 1-to-1? Does every x have a unique y and every y have a unique x? And the answer is yes. This one's fine. Every x has to have its own y and every y has to have its own x. Now the thing about 1-to-1 functions, they pass the vertical and horizontal line test. They are either always increasing, like the x cubed graph. See, that would pass the horizontal line test, it would pass the vertical line test. Or they are always decreasing, going this way. That would pass the horizontal line test, that would pass the vertical line test. So in order for it to be 1-to-1 and pass those things, it's either going to be always increasing or always decreasing. Oh, let me show you my page. There you go. One of the things that they want you to prove that two functions are inverses of each other is what we talked about with that when you're fogging and goffing. If I do f of f to the -1 of x, what's my answer always have to be? Has to be an x. And if I go the other way, f to the -1 of f, I get an answer of x. So they're saying, okay, you got two functions now. Are they inverses of one another? They called one f, they called one g. So what I want to do to check this, to see if they really are, is I want to fog it and goff it. I'm going to fog, I'm going to goff. And I'm going to see if my answer comes out to be x. If it comes out to be anything other than x, then they're not inverses. All right, so that means I need to have an f function. I'm putting my g function, remember that what this means, f of g of x. So I'm finding f of my g of x function, 2 over x minus 3. If I put 2 over x minus 3 into this spot for the x, it's going to look like this. 2 over x minus 3 plus 3. Well, this gets kind of messy, but first thing I see is that I have a minus 3 and a plus 3. So the first move I can make is to cancel those 3's. Well, that's going to give me 2 over 2 over x. That's awful. That's a complex fraction. So that would be the same thing if I think about it as 2 divided by 2 over x, right? And if I'm dividing by a fraction, I'm multiplying by the reciprocal. Keep, change, flip, I think some of your teachers have said. 2 times x over 2. Keep, change, flip, keep the 2, change this to multiplication, flip this guy, x over 2. My 2's cancel, and lo and behold, I get my answer of x that I was looking for. Now, if I goff it, that means I'm taking g of f of x. I'm taking my f of x, we know f of x, putting it into the g function. So if I do it the same way I did the last one, what I want to know is what's g of my f of x function, 2 over x plus 3. I'm taking 2 over x plus 3 and putting it in here. Oh my goodness, now I'm really going to be crazy. I have 2 over x plus 3, and then I have still a minus 3 on the outside. This is confusing. It really gets crazy. But this piece here is like saying 2 divided by 2 over x plus 3. And then I still have this minus 3 on the outside. Keep, change, flip. 2 times x plus 3 over 2 minus 3. Do you see where it's going? It's going to turn out pretty. 2's cancel. I have x plus 3 minus 3. 3's cancel, and I get an answer of x. So yes, they are inverses of each other. Are they inverses? Yes. I fogged and goffed. I got an answer of x. Here comes the last example. Bring the pane. Again, it's algebraically a bit of a cumbersome thing, but here's your story. You're finding this one, they want you to, they didn't really say this. I guess they didn't really say this. Bring the pane, they want you to find the inverse. Well, same 4 steps, right? Step number 1, change it to a y. Well, they already did that for you, so you don't have to do step 1. Step 2 says switch your x and y. X equals 2y minus 3 over y plus 4. And I'm supposed to step 3 solve for the new y. Whoop! How am I supposed to do that? So I'm going to take, and I always think of cross multiplying when I think of these things. Some of you might think of multiply both sides by y plus 4. Same exact idea. Okay, so if I take this, put it over 1, cross multiply, I'll have x times y plus 4 equals 1 times 2y minus 3 is 2y minus 3. Distribute out my x. I'm going to distribute it out. xy plus 4x equals 2y minus 3. Well, my job is to get the y's by itself. So that means they have to be on the same side of the equal sign for me to be able to do that. So I'm going to take my y terms and bring them to the left, and I'm going to take anybody else and put it on the right. So xy, he stays on the left. 2y comes over, becomes a minus 2y. 4x goes to the right because he doesn't have a y in it, negative 4x. And I have the minus 3 that's already there that doesn't have a y either. So all the y pieces are on the left, everybody else is on the right. Then I'm going to factor out a y. Y, if I take a y away from this, I have an x. If I take a y away from this, I have a minus 2. I'm not doing anything on the right. Now think about how I can get this y by itself. It's attached by multiplication with the x minus 2. If I want to move that, I've got to divide. I've got to do the opposite operation. So I'm going to divide both sides by x minus 2. Divide this side by x minus 2, divide this side by x minus 2. And here's what I'm going to have. I'm going to have y equals negative 4x minus 3 over x minus 2. Well, that, my friends, is your inverse. F to the negative 1 of x equals negative 4x minus 3 over x minus 2. and you just found the inverse. That's it. They didn't ask you to prove it or do anything else, thank God, because that'd be really ugly. All right, so let's take a look real quick at some of the practice problems, see if there's any that we really need to do together. I'm looking for each set of ordered pairs, determine if it's 1-to-1. Remember, each x has to have a unique y, and each y has to have a unique x. So that's how you're going to do numbers 1 and 2. Same thing goes for 3 and 4 with mappings. Every x has to have a unique y, and every y has to have a unique x. For these guys, they're a little bit nicer. In order for it to be 1-to-1, it has to pass the vertical line test and the horizontal line test. So that's numbers 5 and 6. Numbers 7 and 8. The question is, are they inverses of each other? Let's try number 8. Now determine if they're inverses. You want to know, and I'm going to put it to the left here, you want to know when you fog that you get an answer of x, and when you goff you get an answer of x. If they're inverses, then that's going to happen. Let's try number 8. So if I fog number 8, I'm going to take f of g of x. So I wanted to know what f of g function is, x cubed minus 3 is. I'll plug it in. The cube root of 3 minus, parentheses, put your f in, x cubed minus 3. And then you're going to work out the details for this guy. So let's see, if I distribute cube root 3 minus x cubed plus 3 is what I'm going to get. I guess I could put my equal on the left. 3 plus 3 is 6. I've got the cube root of 6 minus x cubed. I'm supposed to get an x. Did I get an x? I did not. So this one is a no. Doesn't happen. Let me just double check my work here. I have 3. I'm taking the g function. I got something different on my paper when I did it originally, so I'm just double checking my work here. 3 minus x cubed minus 3. 3 minus plus. Okay. Yep. Doesn't work. Okay, let's try and look at some of the rest of these examples. That's here. So this one, it says the domain, find the domain and range and sketch the graph of the inverse. So what you're going to do with something like this is you're going to pick a couple points, but pick nice points that are on the graph. And this is for number 9 and number 10. See this coordinate here? This coordinate is 3, 4. That's a nice coordinate. This coordinate over here, he's a nice coordinate. He's negative 4, 1. And then I'm going to pick one more nice coordinate, maybe right here in the middle at 0, 2. And if I want to sketch the graph of the inverse, all I need to do is switch the x's and y's. So I want to now plot, instead of 3, 4, I'm going to plot 4, 3. 4, 3 is right here. See how I switch them? Switch the x and y. If I want, my original point was 0, 2, my new point's going to be 2, 0. Well, that's here, 2, 0. And if my point over here was negative 4, 1, my new point's going to be 1, negative 4. 1, negative 4 is down here. All I did was switch them, right? That's easy peasy. And then I'm going to sketch the new graph. Now take a look, make sure you're right, by looking at that line of symmetry, which they actually drew on there for you. This guy right here. And sure enough, if I fold it over that line, I'm good to go. Domain and range. Domain says, all right, for the original, that's this guy, he starts left to right at negative 4, and he stops at 3. The lowest range it goes to is 1. I'm looking at the y values. The highest it goes to is 4. Now pretty much all I need to do is switch them as well, right? We talked about that earlier. So my new domain should be 1 to 4, and my new range should be negative 4 to 3. Check yourself out. This one goes 1 to 4 x's. The y's go negative 4 to 3 the y's, and you're good. So you got that right. All right, graph the function, verify it's one-to-one, make sure it passes the horizontal and vertical line test, find the inverse, do your 4 steps, and then show that it's symmetric with the line y equals x, state the domains and range. So this is like the queen problem of them all right here. This one is like, you do this, you got the whole idea of inverses down. All right, then you're into 12 and 13. They're telling you it's one-to-one. They want to know what the inverse is. Now this one is a lot like the bring the pain problem we just did. So you're going to switch your x's and y's and then solve it exactly the same way we did bring the pain. This one here, let's try this guy. Number 12, change the f of x to a y. Y is 2 over x minus 1. Switch the x and y, 2 over y minus 1. And then I guess it's kind of similar to the bring the pain, but it's just not as big and beefy. I'm going to pretend this x is over 1. I'm going to cross multiply this thing. I get x times y minus 1 is 2 times 1, or 2. Distribute the x. xy minus x is 2. Get everybody with the y on the left. Everybody else on the right. By the way, it can be 2 plus x or x plus 2. Doesn't really matter. And then get the y by itself. That means I have to divide by the x because it's attached by multiplication and I need to undo it. Y equals 2 plus x over x. Call it the inverse. Some kids might want to cancel this x and call it 2. No, you can't do that. You can only cancel out when you have a common group on the bottom or the top. So that's the best you got. And there's your inverse. There's 13. And that's it. All right, then you're into skills review, which you don't have to do. Review skills, you don't have to do those. Okay, so you're left to finish numbers 1 through 13. Shoot me an email if you have any questions, and I will see you in class.